Hi guys, let's start the session. Am I audible? Hello.
Yes.
Yeah, thanks. So let me share the whiteboard first. Yeah. So everyone is able to see the whiteboard. Like the link is in the chat box, so you can. Uh, okay. Thanks. Okay, everyone is able to see the whiteboard. Fine. Okay. So the topic for today's session is heap. Okay. So the topic for today would be heap. So what we will learn today, first of all, we will learn what is the heap. Then we will solve we will see the various operations on the heap and what would be the time complexity and space complexity for those operations. And after that, we will solve some problem related to heap, and we'll try to understand that where we can use this heap data structure to solve our problems in a better way, right? So if I talk about the heap, so it will as we have already learned the tree data structure, binary tree and binary search tree. So the structure would be same, but we are not going to use this node kind of structure. Like for tree, what we were using like this, where we have data in middle or in like in one part of this, and these two are for left and right side, right? So we are not going to use this structure for the heap. Okay, so it will be a simple array. So many most of the student are confused with this. We see the heap as a tree, but we are not using this structure. So it will be in an array, but for representation we will use a tree structure. So it will be like, let's say we have some data, let's say 1, then 5, then let's say 10, like this. So this will be like this, but it will be an array like 1, 5 and 10. Okay, so the we have two kind of heap here, two kind of heap. One is maxi, where it follows some maxi property, and another is min heap. So we have this root. So if we are talking about this max heap, so this element would be maximum element among all the nodes. It will be the maximum one. And if I talk about the min heap, so it will be the minimum one. So that is the property. And apart from this, the full heap also follow the same property with each node. That this node, if we are talking about the min heap, so this value should be less than left child and right child, right? But as I already told you that we are not going to use this tree structure. So how we can find this left child and right child? So there is a formula for like left and right child. So let's say if we are at index I, so the left child would be 2 into I plus 1 in this array. This is the left child. And for right child, we have this 2 into I plus 2. Okay, so we here we like in array we use zero based indexing. So 0, if I put this 0 here, so the left child would be 0 plus 1, that means 1, and right child would be 0 plus 2, that means this 2. And again, if I talk about the child of this, let's say if I am here, so the left child would be 2 into 1 plus 1, that means 2 plus 1, 3, and right side will be 4. So this will be like, let's say we have some other value, let's say 50 and let's say 60. Okay, so this will be the left child for this, and right child for this, and so on. So whenever we are inserting anything, let me scroll down. Like till now we have this heap, we have some properties. So let me summarize all these things. First one, so let's talk about this min heap. Okay, So we are talking about the min heap. So whenever we are talking about the max heap, so just we need to remember that here we are considering the min element, and in max heap we are considering the max element. All other like operation would be same. So here the first value that each root should be less than equals to its childs. The first one and the second one, if we want to find a left child, so we have this formula 2 into I plus 1. If we want to find this right child, so we have this formula 2 into I plus 2. And if we want to find the parent, so here let's say we can generate the formula from here itself. We have 2 into I plus 1 as a this parent, right? Or let's say I. So what we can do, we can find this. So it would be like we can get the parent. For example, here, if I talk about that, what would be the parent for this? This is 0, 1, 2, 3, and let's say 4. So the parent for this is this, and for parent for this is this. So we can simply say that 3 by 2 and 4 by 2 minus 1. So either we can like from this parent we can jump to this left or right child, and if we have a child then we can also jump to the parent. So we can also find the parent, and all the nodes should satisfy this condition. Okay, so we will solve some problem after completing this this theory part. Then we will solve some problem where we can use this, and the best application is a priority queue, where we have some priority. So that priority queue implemented through this heap only. Okay, so now if I talk about some operations, so we have like insert operation, then we have delete operation, and we have heapify. What we can say heapify. So like insert, delete, and heapify. So what we can do, and we can also get here we have get min, get min, and for max we will have a get max. So the time complexity for this would be log n. The time complexity for this would be log n, and for heapify as well log n. And here we will have order of 1. So why it is like most popular data structure? Because we have general time complexity order of log n.
Are you sharing your screen, Shalika?
Yeah, hey Suresh. Yeah.
I didn't see your screen. Are you sharing anything?
Okay, I am writing on whiteboard. Are you not able to see the whiteboard?
No, it's kind of blank screen.
Okay. No one is able to see anything.
I can see your board, what you are writing.
Just a second. I'm getting a call.
Maybe Suresh, try to move. Maybe you're seeing a portion which is blank.
Oh, okay. So I'm not sure like whether you.
Yeah, Suresh, now are you able to see?
Not exactly. So
let me share it again. Just a second. Copy link, and let me share.
usually the whiteboard appears. So today first time.
Yeah, you can check the link I shared in the.
Okay. Yeah.
Now you are able to see.
Okay. So I need to sign in for this. Okay. Let me sign. Okay. Thank you. Then let me try. Yeah. Continue the class. Thank you.
Yeah, okay, fine. So like this heap data structure is important because we have this insert, delete, and heapify operation in order of log n time. But it is not we a good like good data structure for searching, because we have a better data structure. We can say binary search, or we can say binary search trees. So for searching we can use that, but in some cases we need these insert delete operation in efficient way. So we need this heap data structure. Okay. So this heap.
To the whiteboard actually. So it's also request access.
Okay. So are you able to see this whiteboard or not?
It's asked me to submit for request access. I requested actually. So
okay, let me check. Okay, I should get that on mail only.
okay. Yeah, still without.
Just a second.
Sure.
I think Abhishek is already provided you. Are you able to see now?
It's still asking me to either the whiteboard does not have exist or permission needed to for you. So yeah, it's showing that link. So I sent a message to request. So please give access. So I'm sending again. So I don't know where the request will go. Yeah, I sent a request again.
So viewer, okay, interviewer has disabled collaboration with user outside of you. Okay, fine. So let me share my screen so that you can see the whiteboard. Okay.
Yeah, that would be great.
Just a second. Let me share my screen so that everyone can see the screen itself. Okay. I think now you are able to see the whiteboard, right?
Yes.
But here is the whiteboard where I was. It is a Zoom. I think there. Where is my whiteboard now? Wait. Now I don't have the whiteboard option. Okay.
You're just sharing the screen and you're showing the whiteboard. Right? So see here, Suresh.
But
So you got a message actually. Can you please go to your inbox?
yeah, I got the message, but when I trying to provide the access now, I'm got here. I'm getting this. It is disabled.
Oh, okay.
Okay, let me. But here, can I write here itself? Yeah, here I can use the whiteboard, but let me stop. Let me create another whiteboard so that everyone can access it.
Thank you.
Open and collaborate. Just try this one. Okay, I think most of you are able to see the whiteboard, right? Suresh, are you able to see it?
Not so. Are you sharing a separate link actually? Whiteboard?
No, I like the whiteboard is blank. Are you like most of you are able to see?
I'm not sure like what settings are changed actually. So I'm just click on the Zoom link and so I see a kind of blank screen actually. So
Okay, when I'm sharing the screen, so it is the whiteboard is closed for everyone. Let me share my screen and let me use the online whiteboard so that everyone can use
yeah,
this. Okay,
it's
okay,
on,
fine.
actually.
You can see this, right?
Yes, that's correct. Yes.
Fine. So here we were discussing about heap data structure. So we have some operations like insert operation, delete operation, and heapify operation. All of them are in order of log n. And if we want to build the heap, so it will take order of n time in like in average case, but in worst case it will take order of n log n time. But we just need to build a heap only once, then we can perform all the operations. So eventually it will take order of n time, and after that all the operation will take order of log n time. That would be a like good time complexity for like insert, delete, and all these operations. So when we have heap like this, let's say I'm talking about the min heap by default. So whenever we want to convert this min heap to max heap, we just need to flip the rule. Currently we are taking that the parent should be less than its child. So if we are talking about the max heap, so we can simply say that parent should be greater than with the like both the sides. Okay. So let's say we have this 1, let's say 2, 3, 4, 5, 6, 7, like this. If we want to insert it, so we will insert it in the at the last. Okay, so let's say we can insert 8 here. Okay, so it may be like we are inserting 0, or let's say we are inserting, let's say we have this 1, so we are inserting 0. So whenever we are inserting, we should heapify this so that we can get this 0 here. Okay, so that's why we need a heapify operation. That's why insert takes order of log n time, because we once we insert it, we should restructure this heap so that we can create a we can follow the condition of heap. So we can convert it the tree into heap. And I already told you that this is the this is the implementation inside this array. So we are not using a tree structure here. For the simplicity or for the explaining, or we can say for the understanding, we are showing this as a tree, but we are storing all the data and we are performing all the operation in the array. So that's why this is a important data structure, because we are using this operation in an array, and we have a good time complexity. So if I talk about the VST and all, so they have the complex data structure. We need to go through the pointers and all, but here we don't need that complex data structure. We don't need a that node kind of structure. We can perform the operation in this array itself. And for now, we have this collection framework. We don't need to worry about this insert, delete, or heapify operation. But for for the understanding of this data structure, you must know that what are these operations. Okay, but you are going to use this priority queue. So priority queue is basically in backend it is implemented through this heap data structure. So you don't need to worry about this insert, delete, and heapify or get max or get min operations. Eventually, you are going to use this priority queue, and when you are using the priority queue, so all these operations will be taken care by the queue itself. Okay. So, but sometime sometime interviewer may ask about the details of priority queue or this heapify operations. So for that, you should know about this. Okay. So what we can do for heapify operations, this operation only perform when let's say if we are going to perform this heapify operation for this operation this node. So we are assuming that all the this heap, this left heap and right heap is already is a heap. So it is already fulfilling the condition of heap. Then only we can perform this heapify operation for this particular node. When we are inserting this particular node, inserting, that means we are inserting at the end. So when we are inserting at the end, obviously the this don't have any left and right child. So we can perform the heapify operation from here, and we can go till the parent if it is required. Like in case of this, it is 0. So we need to move this 0 here, and 4 will come here and 0 will come here. Then we can perform this operation and keep on moving this till here. Okay. So, but you don't need to worry about this. But if you want to learn this heap data structure, then you should go through these insert, delete, and heapify operations, but they are not required as for solving the DSA problem, because we are going to use the this priority queue, which is in by default is using this heap data structure. The only benefit here that we have most of the operation in order of log n time. Okay. So now let's come to the questions. Which kind of question can be solved through the priority queue or through this heap? So anyone want to explain anything that which kind of question we can solve through this heap? Anyone? Okay, let's start with the question itself and try to answer me how you can solve this the particular problem. So let's say we have 1, 5, 2, 3, 8, 7, 6, let's say, and 8, 8 is always there. So let's say 18 and 5. I just want to know that what would be the third smallest element. Third smallest element. So the first is the smallest is 1, second is 2, and third is 3, right? Are you able to hear me?
Yeah, yes, that's it.
Yeah. So I just want the output as 3. Okay. So just tell me how you can solve this problem.
So convert into a priority queue, and so while we are adding the elements, like what we have to do is we have to keep the size as 3, and whenever it is not meeting the criteria, simply deleting that element, and yeah, bring
Okay.
that.
Okay. Can you repeat? You are what? Which data structure you are using?
We can use the priority queue only.
Okay. Priority queue. Okay.
So what we can do is like we need to have a third smallest element. So what we can do is we can keep the priority queue size of 3 actually.
Mhm.
Whatever the element is not satisfying the criteria, so we'll delete that element and just stay the remaining 3 elements. And out of it, like we'll
Okay. 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 Just try to help me. Let's say we have this priority queue here. Like when we will get this one, so this one will be inserted here, right?
that's correct, yes.
Then I we will get this 5. So what will happen? 5 will be inserted here, right?
Yes, that's correct.
After that, we will get this 2. So 2 will be inserted.
When 2 comes, it becomes automatically priority queue. It maintains the queues 1 to 5 will come in.
Okay. So you are saying it will automatically be like this 1 to 5, right?
Yeah, that's correct.
Okay. 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 After that, 3 will come. So where will 3 will be placed?
Comes and 1 has to be deleted and 2, 3, 5 will be there.
Okay. So you are saying 1, 2, 3, 5. Okay. And then let's say we are getting this 8. So it will be like this. And, yeah.
Because the priority queue size is only 3, so it maintains only the 3 elements in it. So 1 will be deleted.
Okay. Okay. You are saying we should have only the size of priority queue as 3. So let's say when we 5 is coming, what we are going to do?
1 will be deleted actually. So
Okay, one will be deleted. Fine. Then we will get another element.
sorry,
Let's say,
we want the third smallest element, right? Basically.
yeah, yeah,
So then
yeah.
maximum element will be deleted. 5 will be
Okay.
deleted.
Okay. Great. So basically, what we can do, we can we can use max heap here, right?
Exactly. Yeah. Third time.
Yeah. If we want the third and smallest element, we can use max heap. But let's say or the another approach is we can have all the elements, and at the end we can use delete 2 elements, and we can simply return the third one if we are using min heap, right?
That's
So
correct.
what we can do, we can create a heap of all the data, and heap means we can add all the data in the priority queue. And when we are getting the data from this, or we are fetching the data, we will get the first element, then we will get the second element, and then third element we will get 3. But the data will not store like in a sorted order. Okay, it will be like this: 1, 2, 5, and 3. Okay, how it can be possible? Because we are like maintaining this heap. So 1, then 2, then 5, and then 3, like this, right?
Yeah.
Are you getting me? So it is not sorted, but it is somehow arranged in such a manner that every parent would be the minimum with their child. So it will follow the heap structure. So we don't need to worry about this 5 and 3 because they don't have any relation, right?
Can you tell me like what are the conditions to satisfy a heap actually?
So basically, heap will have every parent should be greater than their child. Oh, sorry, for min heap, it should be less than their child. So 1 is less than 2, and 1 is less than 5. That is fine. 2 is less than 3. That is fine. Let's say we have 10. So okay, let's say we have 4 here. Then we have 10 here, and let's say we have 6 here. Okay, so this 4 is less, 2 is less than 4, 5 is less than 10, and 5 is less than 6. So we don't need to worry about that left child should be less than right child and all. So we don't need to worry about that. We just need to follow the condition that the parent should be great. In the case of max heap, it should be greater than, and for the min heap, it should be less than its child's. And keep this should follow the same condition. So the structure look like this: 1, 2, 5, 3, 4, 10, and 6. So this would be a heap, but it is not in a sorted manner. But when you get the element one by one, so you will get 1, then 2, then 3, then 4, then 5, then 6, then 10. Why? Because every time when you delete this one, so automatically the last element, this 6, come here, and this 1 will be deleted, and then it will run the heapify operation. So it will again convert it like this, something like this, that 2, then because we have this less value here, so 6 will come here, 5 and 10 will remain same, and here we have 3 and let's say 4. So we have 6, so it will find the minimum element. This 3 is minimum, so it will be like this: 2, 3, just a second, 6 and 4, 4 and 5 and 10, like this. So it will ensure that it will follow this heap condition, but it will not ensure you that the data will be in sorted order. Okay, the first thing. So sometimes we get confused that, okay, as we are getting this sorted data, when we are fetching the data, so that means we are putting all the data in a sorted array. So if that is the case, then we can get the element, we can sort the data in order of n time, right? Right, because the creation of this heap is order of n time. So we can sort the data in order of n time, but that is not possible. So initially, eventually we are having this kind of structure. So every time we have this kind of structure, it is not guaranteed that the data would be in sorted order, but it will be in a way that it will follow the min heap property. Okay, clear or not?
Yes.
Okay, so the data may be in any order, but it should be like I already explained that we can jump to any child. So this is the left child and this is the right child. So both of them should be greater than this. Similarly, this is the left child for 2 and this is the right child for 2. So these two should be greater than this. It may be 13, it may be under anything. We don't need to worry about any other thing. We just need to check with the parent and child and keep on checking for this 10 is greater than 5 and this 6 is greater than 5. So that means this is the structure of heap. Okay, and it may be like this as well. Maybe we can say that let's say 3 is there, or 3 maybe here, and let's say 6 is here, let's say 4 is here, and 5 is here, and let's say 3, so 5, okay, 6 is here. So this is also a heap structure. So the same data may arrange in various form, right? Because we can have 6, let's say 6 here, and we can have, let's say 4 here and 5 here, like this as well. So this is also a min heap because it is following the min heap property, right?
Yes.
That's why for every deletion, for every deletion we need to run the heapify. That's why the delete operation take order of log n time, right?
Understand.
Okay, but if we want to get that element, only get element, not deleting. If we want to get that element, minimum element, so it will take order of one time. One time. Why? Because we are only copying the value of the top element. We are not deleting it. If we are deleting it, that means we need to run the heapify algorithm. Okay.
Understand. Got it.
So there are 2 options. Either you can get that data or you can pull that data. So pull means remove that data. So whenever you are removing that data, that means you are running this heapify algorithm. And when you are getting that data, that means you are copying that data. Okay. That means the tree will be same, but you are simply what should I say? Only you are copying the top element, root element, right? Got it? And delete means you are removing this. So when you are removing this, so all the data will be rearranged according to the heap algorithm. Okay.
Understand.
Got it. So let's forget about the heap and solve the problem without heap. So we have the data. Let's say 1 3 1 3 2 8 5 6 7. Let's say 10, and we want the, let's say, fifth smallest element. Okay. So just forget about this heap data structure and just try to solve this algorithm without heap. What will be the time complete? Then we will compare that. Okay, we have the better solution through heap. So how we can solve this?
We can sort it actually. So with sort again, it takes order of n log n max actually.
Okay,
Then once we
what I can do. Let's go with the brute force. So let's forget about the sorting itself. I just want the fifth element, right? So what
Yes.
I can do, I can go with this first element. I will get this first element, let's say 1, and I can delete it or mark it anything. Let's say I can mark it as infinite. Then I will get for second element and I can mark it infinite. And then I will get the third, every time I'm getting the smallest element, right? So the first smallest element would be 1. So I will mark at infinite. Now I again find for minimum element, that would be 2. So I again mark as infinite. Again I will find minimum element. I will get 3. I again mark this infinite, and again I will get the next minimum element 5. So I will again mark this, and now as I run the loop four times, now if I get the element, that would be my fifth element, right? So 6 will be the answer, right?
yes, yes.
That would be the brute force algorithm. We can solve the problem by hook or crook. Okay, and the complexity would be order of n into order of this k. We can say this k. Okay, so in worst case, this will be a n. So it will be around order of n square, right?
That's correct.
Now let's come to the second approach that we can sort this data. So basically, in worst case, we are having this order of log n square time complexity for sorting, but in average case, we have this sorting algorithm with order of n log n time, right? So that is better than this algorithm. So what we can do, we can sort the data. So the data will be like 1 2 3 5 6 and so on, and we can directly jump to the particular index, right? This
Yes.
fourth index, or we can say, if we are talking about the one base indexing, so fifth index. Otherwise, as array has zero base indexing, so we want to find the fifth element, so we can simply jump to the fourth element, right? Fourth index, and we can get this. So the time complexity would be order of n log n. That is better than this. Okay, now can we have something else? So yeah, we can go with this heap data structure, where we can run this algorithm, and we can maintain the heap size, as you are explaining, that we can maintain the heap size, or we can simply create a heap with all these elements, and then we can delete the element, right?
Yeah.
We can maintain the heap size of particular let's say 3, or in that case, what we can do, we can take a size of n minus k. Okay, like we want the fifth element, so either we can go with the max heap with the size of 5, or we can go with the min heap with n minus k size, right?
Got it. Yes, that's correct.
Okay, got it?
Yes.
So both are the similar things. Like here we have 5 element in the queue, but in if we are going with min heap, so we can go with 1 2 3 4 5 6 7 8. 8 minus 5, that means 3 element, right?
Yes.
So we can go with this as well. And this when we want to get that element, we can simply get this element through this get operation. But when we are deleting it, so we should run the heapify algorithm. So if we are taking the lesser size, that means for heapify algorithm, we are taking less operations, right? That's why we are preferring this one. Otherwise, what we can do, we can create a simple heap with the full size, size of 7 or 8, whatever, and then we can delete 4 element, and then we can get the fifth element, right? But
Yes.
in that case, whenever we are inserting any element, we need to run the heapify operation for all the elements which are present in the heap. So we will try to go with this less number, so that we need to we don't need to perform the heapify operations for all the load. And eventually we have this when we have heap, so we have if we want to find the number of roots, so root would be n by 2, this lower bound, plus 1 to n. So we will have around half of the node would be the root node. So we don't need to run any heapify algorithm for those leaf node, right? Let's say if we have a tree like this, so it doesn't have any left or right child, right? So it is if we have a single node, it always satisfy the min heap property as well as the max heap property, right?
Yes.
So we have n by 2 plus 1, around half of the this node would be the root node, right?
Got
So
it.
when we are going with the size of 3, so we are only performing the operation on this only, heapify operation on this top node. We don't need to perform anything here. And let's say we are going with the size of 5. So let's say 3, 4, and 5, right? So we just need to perform this operation in these 2 nodes, right? And these 3 are leaf node only.
Okay.
Okay. So now you don't need to implement this heap operation, insert operation, delete operation, like in your DSA problem. You simply need to use this priority queue for solving these problems. So we have this collection framework where you can use this priority queue for the solving these problem. So let's jump to the problem itself. Okay. So we have this this is the heap itself. Yeah. So let's start with the first question. So okay, before that, let me check if we have the same question, this whatever we have solved. So currently we have solved for the smallest element. Here we are talking about the largest element, kth largest element. Okay, so here we can use simply min heap, right?
Okay. Yeah.
So this this can be solved through the same operation which we were discussing on the whiteboard, right?
I have one question, Shalikam. So, when min heap traversal complete, so do we get in a ascending order actually the list, or like descending order?
Sorry, can you repeat your question?
When we perform a complete min heap traversal, basically, what do we get a ascending order list basically?
Okay. So that I already explained, basically, that when we are performing any what should I say, traversal, we are not going a fixed order, fixed element. We can get any random element, but the condition should be like this. We should have this parent and child relationship. So we can have like this if we are going to traverse it. But when we also have this heap sort, right? So basically heap sort means we are deleting element one by one and putting into another array or same array. So that is the different thing. But when we are traversing it, we will get like this: 1, 3, 4, let's say 6, then 5, then 10, and 6, like this, whatever I have explained here. Okay.
And now basically min heap means we can construct a tree, and as we deleting the root element, every tree, you get a kind of ascending order, right?
Yeah. So when we are deleting it, that means we are running the heapify operation.
Got it. Yeah.
So in deletion, we will delete this 1 from here, and then we make the minimum. We will find the minimum element in the tree, and tree or not tree, because the representation is tree, but we are using this array. So we will find the minimum element, but we will find the minimum element in order of log n time. Okay. In the array, we need to find the minimum element, so we need to we need to run the algorithm in order of n time. But in heap, because we already have the special representation or special arrangement, we have this parent child relationship, that all the parents should be less than their child. right? So we don't need to go for all the data. We can directly go with the log n time, and we can get this data, right?
Yes, yes.
So every time we will run this CP5 algorithm when we are deleting anything. Okay. So if you are traversing the tree or traversing the this data, so you will won't get this sorted order. It may be in sorted order because eventually sorted order is a also a min tree min heap. Okay, so if we have the sorted data, that is also construct the min heap. So this would be one possibility, like you may get the data as a sorted data, but it you cannot say that you will get the sorted data every time. Okay.
Understand, understand.
Okay, great. So okay, so the scale largest element, we can find the scale largest and k smallest element, right?
Yes.
Now we have this k okay array, and we have let's start with the first question. Top k frequent element. Here the question is like this: we have 1 1 1, then 2 2, then 3, and we want this the second the element which has the highest frequency, second highest frequency, right? So the frequency of 1 is 3, frequency of 2 is 2, and frequency of 3 is 1, right? So the highest frequency is 3, the second highest is 2, and third highest is 1. So we just need to print this the second highest. Okay, top k. Okay, top k. That means we need to print the highest one. That means third. We have the frequency 3. Then we need a second highest. That means 2. So we need the answer like this. Okay. Like, are you getting the question or not? Let me get the question on whiteboard. Yeah. And with the different example. Okay. So let's say we have this 3 3 3 5 5 5 8 6 5 3 9 3. Okay, and 1 1 1. Okay. Now I just want two highest frequency. Like, so we have this the frequency of 3 is 1 2 3 4 5. Okay, 5. Then the frequency of 5 is 4, and the frequency of 8 is 1, and 6 is 1, and 6 and 5 is 1, and let's say 1 is 3. Okay, so I need two values. So the first would be this 3, and second would be this 5, right? So the answer would be 3 and 5. If we want the 3 values, so the first frequency would be 3, then we have 5, then we have 1, right? 3, 5, and 1. Are you getting the question?
Yeah, yeah.
Okay. So now tell me how you are going to solve this problem. This is a like quite difficult problem. We can say it is a medium to hard problem, but it would be similar to this. It would be similar to this, but here you just need to structure your data. Then you can use this heap operation, or we can say priority queue operation.
I don't know. If in an interview this kind of question comes, I think I'll probably, since we're doing heaps, maybe, you know, we're trying to think that way. But I think the first approach would be to create a something like a map or something, and then.
Okay, so eventually we need to create a map itself, because then only we can get this frequency. Then we should use this heap. So you won't get the question directly from particular data structure. You may need to convert your input data into particular data structure. You need to store the data your data into particular data structure, and then you need to perform some operations. So here okay, so here we need to use this heap. Okay, so now can you solve this problem?
Yeah,
you are saying that this is the heap class, so we know that we need to use this priority queue. So
I think first convert it into the hash map, or
okay,
and we can convert into hash map, and we can reverse the key to value, value to key.
Okay, so
but there is
eventually,
one problem
you need.
there actually.
Okay, great. That is a great concept. Basically, what we are doing, we are creating this map, and then we are reverting the map, or we are creating another map. What do you prefer?
But
Reverting a
there is
map,
one
or
problem, Shalikram, is like, suppose like you have 8 is one time and 6 is one time and 5 is one time. So
Mhm.
reverse
So
it.
eventually, you may have this here. You will override this, so 8 will be gone, 6 will be gone, only 5 will be there. For now, let's assume that okay, you have these unique keys and unique values. Okay,
Okay.
let's forget about this. So you have unique keys or unique value. Now what you will suggest? Let's create a map here. This
Yeah,
map
we
is
can create a
already
map
created.
and we can revert it.
Okay, so for reverting it, you are reverting the same map, or you are taking another map.
I think we have to take another map, otherwise it will
Yeah,
override.
because we again need these values, right?
Yeah, exactly. It will override something actually. So
Yeah.
that,
So okay, you are saying like this 5 3 and 4 5, and let's say this 3 1, right? Okay.
yeah, that's correct.
Now
And
you are constructing the heap from these data structure, right?
yeah, I'm constructing again like we need to do the some kind of sorting. So again, we have to perform basically, right? Otherwise, we won't get that. So
Okay. So here you can use a max heap or mini heap, whatever suits for this, and you can put like, we need 3 values. So what we can do, we can have the
delete
size of,
one by one. Yeah.
yeah. So if we are getting more than 3, so as we need a maximum frequency, so let's say the smaller number will come, so we can use a max heap here. Okay. So max heap, whenever we are getting, let's say this frequency of 1 or 2, we are going to delete that. Okay. And eventually we are getting this. Now
That's
we can when we are getting the data, so we will get this 5, right? Then we will get this 4. Then we will get this 3. But the data should be 3, 5, and 1.
No, we have to maintain the value also while we are
Okay.
traversing.
Eventually, we don't need to maintain that because we already have this map. So whenever we are getting 5, we can get the value from this map
Exactly.
only.
Yeah, we have to get
We
that
don't
value.
need this map anymore, because we are having this value, and we can get the data from here, right?
That's correct.
Okay. Now the problem with this, we can solve this problem if we have all these unique values, but we know that these are not unique, right?
Yeah, so that's where like we have to construct a key to value as a list actually.
Okay. Let me tell you that your approach is perfectly fine. You should go with this only. But can you avoid this thing? Like we cannot create this map, but we should use this same logic. Can you do this? Okay. If you are if you have practice on sorting algorithm, or like if you want to sort some pairs, so have you modified some collection framework, collection function with the
Yeah,
comparator or all?
exactly. Yeah, that's where like we have to do comparator. We have to do.
Are you relating this with that? Like let's say we have pairs, so we want to sort the data on the basis of second value, right?
Got it. We use the comparator. I think we can do that.
Yeah. So, not comparator, because comparator is used for this the sorting part. But here we can modify this priority queue in a way that whenever we are like doing something, so comparison should be perform on this the value part, and the like operation will be perform on the key part, right?
That's correct. Yes.
Okay. So when we are saying that okay, this is the class for heap, so we can think about the heap. But if it's not a heap class, or if we are getting the same question in the interview, how we can solve that problem? So when we are getting the problem in the interview, no one wants you to find the solution within 5 minutes or within 10 minutes. They just want to analyze your thinking ability, that how you are going to approach to the problem, because they are hiring you for solving like some new problems in their product, Okay, they are not hiring you to solve some DSA problem which are like top listed on let's say interview bit or lead code and all. They don't want that you should solve this DSA problem. They through this DSA they just checking your ability to fight with the problem and come to the solution with the efficient manner. So what you can do, you can simply go with the brute force approach first, then and let's say if you have the solution set, then if you have enough time, let's say the interview would be for let's say 45 minutes or 1 hour, and they are asking 2 questions, so you should not go directly to the best solution, because then the interviewer will think that okay, you have solved this problem previously, that's why you are able to solve this problem. So when you face the problem, you should think the basic perspective how you can solve that problem. Then you should either you or your interviewer will tell you that okay, your solution is correct, but the time complexity is like not good. Can you optimize it? Or they will give you some hint. Then you should go for the optimal solution. Like in the real product as well, you will face a new problem every day, and you need to solve that problem. So if you have a good habit of solving the problem with the iterative approach, so most of the this product based company are using CI/CD, that means continuous delivery, continuous development process, where they will build a solution for a temporary purpose. Let's say if I am having a requirement, or my client is having a requirement for particular functionality. So the first goal should be to provide the functionality. So it may be not an efficient way, but you can simply give them the this functionality. Then you will get the sufficient time. Like when your client or your testing team is testing that functionality, they are giving the feedback. In between, what you can do, you can optimize that, and you can provide the better approach for that for the problem. Or what you can do, you can enhance your particular solution, so that it would be better for the, in terms of complexity or in terms of space and all. So never try to go with the efficient solution in the first attempt. Just try to understand that okay, that is the problem. Similarly, Suresh has already explained the problem through this heap, but I go with these 3 approach. Like first we can go with this, we can put this infinite and all, then we can go with this sorting, and then I'll come to this using this heap. So similarly you can do for every problem.
Sure. Thank you, Shalikram.
Yeah. So now I think you can solve this problem, right?
Yeah, sure. Yes.
But remember, if I am going to write the code, it may take 10 seconds, 10 minutes or 20 minutes, or it might be possible that I forget some how I can use this comparator and how I can modify. So I need to use the Google and all. So if you are preparing for the interview, so you should solve as many problems as you can, so that you will get a habit of solving this problem using this syntax, like how you can use this comparator and all, how you can modify particular the given function. For example, if I want to solve this, I have the internet, I can check for the syntax that okay, how we can use this key and value in the priority queue, and I can solve this, no issue. And in the organization as well, I have internet access, so I can solve that problem in the organization as well. But when you are giving the interview, you don't have that internet facility in most of the time. Or let's say if you have the internet facility, you don't have sufficient time to surfing the every syntax. Like for some syntax, you can ask from the interviewer, or you can search on Google, they will allow you. But let's say if you are defining the array, but you forget that how I can define the array, right? If you forget that how to what is the syntax of running particular syntax, particular, let's say while case, or let's say switch case, so it will be difficult for you. So if you are practicing it, so it will be helpful. You don't need to think about the syntax, you just need to think about the logic. So this problem can be solved through this. You can try that. And the next problem, let's come to the next problem. So the next problem is similar. Here we have words in place of these numbers. We have these words, so we can again create a map of these things, and we can again use the heap, right?
Sure.
Yeah. So you can you can create your profile here, or you can practice these questions, right? Or you can practice from lead code as well. So here we have this lead code link, so you can copy this link, or you can directly search on this, or you can follow Google itself. You can search the question related to heap and solve it. And we also have this practice question, so you can solve those as well. And then we have k largest element in array, that is already we have solved. Then we have closest point to origin. Here, how you can solve this problem? Let's discuss this problem and wrap up the today's session. So here we have k closest point. So here we don't have this particular value. Here we have coordinates, x and y coordinate. How you can solve this problem? Just forget about the heap. Just think how you can solve the problem. Like if you don't have the knowledge of heap, then we will come to the heap. Like let's say similar to this question. Just think about the solution, because you don't have the distance. You have this coordinates.
What we have to do is, I guess, like from origin to the coordinates, calculate the distance and maintain that distance and the coordinates as a kind of key value pair again, and do the comparator and bring the latest, like bring the order of it actually based on the distance, and retrieve the values actually.
Great. So here, what is required? Like the same this question, we need this frequency here, but we are not going to use that frequency in the heap, but we are going to use the property of the property of heap for this values, right? So we have generated this value and we have put them into the map, and then we are using that. Similarly here, we don't have the distance, but we know that we can find the distance from this origin, or like from 0 0. So we have the simple formula. We can convert the all the values, like all the distance from this coordinate, and we can put into a map with the this pair to distance. So the map should be key should be the pair, and value should be the this distance, and we can apply the same operation whatever we were applying for this, so we can solve this problem, right?
Yeah, yes.
Okay, great. So just try to solve this problem. If is if you are going for a Google, they will definitely ask 1 or 2 questions from heap, because Google has 3 or 4 rounds for DSA only. So you will see at least 1 or 2 questions if you are going for Google, for sure. So it looks like quite simple when we talk about the heap only, but the application is quite like difficult, and the level of problem is quite difficult. Let's say if I tell you the next question, okay, this is the cheapest flight within K stops. So if you solve this, it will the level of this question would be hard. So or you if you let me check this, it must be asked in Google. So this we have company tag here. No, we don't have company tag. Okay, we don't have company tag here. Okay. So in Google, like you can expect at least 1 question from here.
Sure.
So okay, so you should practice these questions, and yeah. So let's wrap up today's session, and like if you like you will get the recording for this session and previous session. I think here, let me check. Yeah, here itself. Let's say graph. yeah, you will get the recorded session here itself. So you will get the session of graph and binary search tree. Yeah, you will get all the sessions like this. Similarly, you will get the same session on this heap. And the next session would be have you solved the problem on graphs?
Not much, Shalikram, actually. So,
Yeah. So we will
discussed
cover some problem in
concepts of graphs actually, but we haven't solved any problems. Sort of like this week we have problems on graphs, actually. But I think priority key is kind of one good introduction, like solving many problems. So yeah, it's good. Actually. So,
Okay. Try this priority queue, and we will again discuss graph questions in this topic, DFS and VFS.
Yeah.
So either we can go with the DP for the next session, and then we will go for this DFS VFS, where we will solve a problem from graph. So this graph problem would be like asked in to the this is also a graph question. If I tell you this, the last one. This is also a graph question eventually. It can be solved through heap, but it will use the concept of graph itself.
Okay, sure.
Okay. So if you are not able to solve this, what you can do, you can